This video is for invented strategies of addition. So I'm going to go over 3, but I'm going to start off with counting up. Now you don't have to use a number line when you count up every time. I just found that to be the easiest way to show it and for y'all to visualize it as I explain it. But you definitely don't picture a number line every time you count up in your head. And students certainly don't either. So to start off with, I wrote out this addition sequence. So 158 plus what gives us 415? So when you give them something like this and you're wanting them to come up with the counting up method on their own, this definitely is going to get them to think in that way. So I have 158. How many more do I need to get to 415? Okay, so to start off with, let me get a different color. I'm going to start with 158 over here. Okay, so students know very easily at this point how to count by ones, tens, and hundreds because those are their place values. And at this point, place value has been taught heavily, or should have been taught heavily to them. So it's, like I said, 158, add 10, it becomes 168. Add 100, it becomes 258. So these numbers are very friendly to use in their head. So that's what they're going to usually count up using. So 158, I'm trying to get to 415. What is the easiest number I can use to do that? So I don't know about you, but my brain automatically wants to add 2 ones to make this 160. So 1, 2, and I'm going to make this smaller. And now I have 160, and I added 2 ones. And I always label what these are because I'm not going to draw them perfectly at all. You will see that. Okay, so now I have 160. I'm trying to get to 415. What is the easiest way to do that? So you can do that a couple different ways. You can add hundreds, or you can do it this way. I'm going to add tens because my brain wants to add 4 to the 6 to make it a perfect 10. So 160, 170, 180, 190, 200. So now we're at 200, and I added 4 tens. Okay, I'm at 200. I need to get to 415 still. What do I do? This is when these hundreds come in handy. So we can say 200, 300, 400. And I'm going to need a little bit more number line here. Okay, I added 2 hundreds. Okay, so now I'm at 400. I need to get to 415. The easiest thing to do is add 1 10 and 5 ones. At least for me, that seems to be the easiest, but there is many ways you can do this. 1 10, not tens. Okay, so now that I've gotten to 415, how does this help the student come up with this number that they need? So now that they know place value, all they have to do is go through and say, okay, how many ones do I have? Or they can start with hundreds, it doesn't really matter. I have 2 ones here, and I have 5 ones here, so I have 7 ones. Okay, now my tens, I have 4 tens here, and I have 1 10 here. I have 5 tens. And then I have 2 hundreds. So, by looking at this, they know that they have 257. So 257 plus 158 is 415. Now this is also when I like to do a tape diagram. I showed those in the standard algorithm video. Like I said, they didn't really help me so much. I don't remember a teacher ever showing them to me. But I love that it shows. So this is going to be 158. And this is 257. So when you do this, it's showing them that this number plus this number is going to give you a total of this number. Because when they get into the older the higher grades of math, if they just see this as an equal sign, they're not really going to understand that this, it has to be the same as this. So this also means the same as. So these two put together is the same as 415. And that's what the tape diagram is showing them. It's showing them that this piece right here needs this piece as well to equal 415. Okay, so question. If they're given 158 plus 257, can they get to 415 using this counting up method? They definitely can. They would just do it a tad differently, especially since I'm using the number line. I'm going to go ahead and erase all of this. Okay, so since we're using the number line, and like I said, you don't have to use the number line when you're counting up. I just chose to because I feel that it's easier to visualize and to explain with. So when you're using this, like I said, they know place value. So the easiest thing is to start them off at 0. And then they can just look at the number. And they're also going to use ones, tens, and hundreds for this because they're more friendly to work with. So they can look at it. They can do this many ways. They can look at it and say, okay, 2 plus 1, I have 3 hundreds here. 1, 2, 3. I'm at 300. I'm just abbreviating. Okay, I have 10 tens here. So they should know 10 tens is the same as or equal to 100. So they can add another 100 here. Okay, so now they have 8 and 7 ones. So they should already know how to add single digit numbers at this point because you're teaching them to add multi-digit numbers. So they should know 8 plus 7, that gives them 15. So when they hear 15, they've been taught place value. They should know that that's 1 10 and 5 ones. So 1 10 and 5 ones. 1, 2, 3, 4, 5. And they know that 400 plus 15 is 415. It might take them a second, but they can do that because, like I said, tens are perfect round 10 numbers, are very friendly to work with in your head. 400 plus 415, that's easy for them to say, 400 plus 15, I'm sorry. 400 plus 15, that's easy, that's 415. Nice zeroed in numbers are easy to work with. So, now that they have that, how does that help them get the answer? They can do it just like the other one. I have 300s here, 100 here, that gives me 400. I have 110 here, and I have 5 ones here. Okay, so they may do it this way, they may also do it this way. Or, they might skip these steps altogether and just say, 400s, 110, 5 ones, 415. Any of these work. And like I said, they may not even visualize this whole thing in their head. This might look super complicated and way more complicated than the standard algorithm. But when you do it in your head, you're not visualizing all this. You're counting up. And it may not be as difficult as it looks. This might work better for some students than others. Simply because you're counting up rather than following the procedures, carry that one, round up, all of that good stuff. Okay, the second strategy that I want to go over is breaking numbers down into more friendly numbers to add. So in these invented strategies, they're usually all about friendly numbers. Trying to find numbers that are easier to add in your head, numbers that you won't have to round, numbers that you won't have to carry, numbers that you won't have to think about so much that you forget what the problem was. So this method, you break it down. I'm going to start with really easy numbers to add just to demonstrate. So 7 plus 5. That might not be so hard for us to do in our head because they are single digit numbers. But for a student, this could be them going 7, 8, 9, 10, 11, 12. Okay, it's 12. So instead of them counting on their fingers, what you could have them do, you could say, okay, what plus 7 gives me 10? 3. Right. So you can break this 5 down into 3 and what? 2. So here's your 10 right here. Maybe I should have used a different color. Here's your 10. And how much do you have left? The 2. And it's 12. So in your head, again, you're not going to see all of this. It might be quicker than that. This might look harder than just saying 7, 8, 9, 10, 11, 12. But once the numbers get bigger, this might help a little more. So, for example, let's do 182 plus, and I know my 2's change all the time. I don't know why. My brain decides to do 2's this way and 2's this way sometimes. I don't know. It's the same thing. Okay, 182 plus, I don't know, let's do... Okay. So, my brain automatically wants to add this 20 to this 8 to make it 200, but I do have these 1's here. So, I'm going to go ahead and split this 25 into a 20 and a 5. So, I know that 180, you can also do this if that helps, that 180 plus 20 gives me 200. So I use this 180, I use this 20, what do I have left? I have 5 plus 2. That gives me 7. So how easy is that to just add 7 to this 200? That's what I hate about the standard algorithm. Hate's a strong word, but for standard algorithm, learning that and only that method growing up, I was constantly trying to put the 25 under the 182 in my head. And this doesn't look that complicated, but when you're first learning, trying to put this under this one in your head and then adding down the rows and carrying the 1, it's a lot to keep up with in your head. Rather than this method, we can do another one too. You're just breaking it down into easier numbers to add. So, I don't know if y'all can see that color too well. 257 plus 128. Okay, so this is a pretty advanced problem for them, but you can still break this down. So I'm going to break this down into 120 and 8. And I can break this down into 250 and 7. So now I have 7 plus 8. Now, they might understand that that's 15 at this point, but they can also break this 7 down into 2 and 5 and say this is a 10, so I've used this and I have 10. They're going to be able to look at this and use place value, say 5 10s plus 2 10s, that gives me 7 10s. And then 2 and 1, that gives me 300, so I have 3 plus this, that gives me 80. And now I've used this and this. All I have left is this 5. So my answer is 385. Now again, this might look ridiculously confusing. It can look confusing to some people, but in your head, this might be a little bit easier than trying to put this 128 under this 257 and then saying 7 plus 8, that's 15, 5 is at the bottom, carry the 1. When you're doing that in your head, you're trying to remember what your answer is, as well as trying to remember how these line up together and where the 1 was carried to. It's a big mess in my head. So this way is a little bit simpler in your head to keep up with all the numbers. And this may not have been the easiest way to do this. With these same numbers, another way to do this, you can say, okay, so I have 257 and I have 128. Just divide them. Just separate them out. That way you can say, okay, I have 300. I I've used these. I have 57 and 28 left. Okay, so I know that 5 plus 2 is 7. So 70. So essentially what I just did, I broke this into a 50 and a 7 and a 20 and an 8, and I used the 50 and the 2. So you see, I just did that in my head, but I didn't write it out. I didn't visualize it. I just went ahead and did it, but essentially that's what I did. So I have a 7 and 8 left. I know that's 15. So we have 385. And that's how invented strategies work. They're little shortcuts that we find in our brain to add. So it's not, you need to learn this method and you need to use this method for this week. Next week we'll start on a different method. This is one method that you can use, but there are so many others that you can use too. Find the one that works best for you. The last invented strategy that I'm going to go over is not one that I particularly like. It's not one that I find easier to do. I'm simply going over it because I've seen a ton of people bashing it on social media. So this way of adding, I don't think I've ever seen a student come up with this on their own, like I have the counting up method or the breaking apart method. Those are ones that students will come up with on their own if you give them an inquiry-based lesson. This one, probably not. I would be completely shocked if they came up with this by themselves. This is just another way to add, and if the students like it, I mean, who are we to tell them that they can't use it, right? Okay, so this way to add is called lattice. And like with the standard algorithm, it's much simpler if you line up the columns, the ones, the tens, and the hundreds, because you're going to be adding down. So the difference between lattice and standard algorithm, we're going to create a little box right here, and we're going to give each column its own little box, its own little square. Sorry, I don't know why that was bothering me. Okay, so now we're going to divide each of these little squares into triangles. This triangle, this bottom one, is always going to be the ones. So this is the ones, this is the ones, and this is the ones. Place. Ones, ones, ones. This top one right here, this is always going to be the tens place. And you're not going to need more than that. Some people, when I teach this, they're like, where's the hundreds? What if you need a hundreds? A one-digit number plus a one-digit number is never going to be needing 100 place. Like, it's never going to be 100 and something. You're only going to need a ones place and a tens place. Okay, so with this, you do not have to start in the ones place like you do in standard algorithm. You can start in any column you want as long as you keep the tens together, the hundreds together, and the ones together, and so forth. So I'm going to start in the tens place just because that's super weird. So 2 plus 0, that gives me 2. So this is my tens place. I don't have any tens. This is my ones place. That gives me 2 ones. Okay, so now I'm going to go to the hundreds place because that's weird too. 3 plus 2, that gives me 5. I don't have any tens in that, but I do have 5 ones. 8 plus 5, I'm moving on to the ones. That's all I have left. 8 plus 5. What is that? We know that's 13. So, I have 1 10 and 3 ones. Okay, so now that I have this, how does that give me the answer? Because this doesn't look like an answer to me. So, all you have to do, you're going to add diagonally down these little diagonal rows. So, this 3 pops out the bottom because we don't have anything to add to it. This 1 plus the 2, that gives me 3 down here. 0 plus 5, that gives me 5, and this 0 just pops out the side. So my answer is 533. Now, how in the world does that work? So I'm going to do a little standard algorithm over here to demonstrate how that works. Okay, 8 plus 5. That's 13. Okay, so now we have the 3 here. We kind of carried the 1 here, just like we did here. Because now we're adding the 1 to the 2, just like we did here. So 2 plus 1, that gives us 3. That's exactly what we got here. 1 plus 2 is 3. Now, we get 3 plus 2, that gives us 5. That's exactly what we got here because we added down the row. So instead of carrying the 1 for an unknown reason, because many times when they're taught the standard algorithm, they're not taught why it works, they're just told to carry the 1. They can actually see that this is a 10 and this is a 1, and so we're going to add it to the next column. We're going to add it to the 10s so that it's not 13 ones hanging out in the 1's place. We have 3 1s and we have a 10 that we're going to add to the 10's place. So now we have 3 10s. It's the same concept, this is just visualizing it a different way. So like I said, students aren't going to come up with this on their own 9 times out of 10. This is something that they would be taught, and if they like it, which I haven't personally met a kid who liked this better, but if they did, this is a perfectly okay way to add. It might cause more issues down the road if they're given horizontal problems instead of lined up vertically and they have to do like a time thing. One of the other invented strategies might be better, but this one is a perfectly okay way to add, and it's not as difficult as it looks.